And today we are having our lesson 2, which is going to be on Newton's laws of motion. Remember now, it is a continuation from yesterday's lesson because we are going to deal with 3 Newton's laws of motion, which is your Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. So yesterday we dealt extensively with Newton's first law of motion. We also dealt with Newton's second law of motion, where we gave introduction. Now, today we are going to go deeper into Newton's laws of motion, and we are basically going to start to look at forces deeply, where we will be drawing those particular forces. We will be calculating the net force, and we will be calculating the acceleration of an object. We will be calculating the mass and so on. And therefore today, our lesson will deal with all of that. And in our third lesson, that is when we are going to deal with your Newton's third law of motion, but also with some of the questions that we are also going to deal with. You will see that we need to apply Newton's third law of motion in other instances. Now, my dear learners, we are going to proceed. Today, I want us to really look at examples and write down and, just be interactive more than dealing with a PowerPoint presentation. So this is where we are going to begin. Right. My dear learners, today we are going to look at forces, and we are also going to apply Newton's laws of motion. Now, this is what you need to understand. Now, let us say we have an object, and our object has a mass of 2 kilograms, and that object is on the ground. And then a man comes and pushes this box, and the man applies a force of 20 newtons, which goes to the right. And then the object experiences a frictional force of 3 newtons. Now, the object here has a mass of 2 kilograms. Now, the applied force has a magnitude of 20 newtons. Remember now, our force is measured in newtons. So it experiences an applied force of 20 newtons to the right, and it experiences a kinetic frictional force of 3 newtons. Now, if the kinetic frictional force is acting to the left, then we are definitely sure that the object is moving to the right. Now, how do we know that the object is definitely moving to the right? Because the frictional force, by definition, is the force that opposes the direction of motion of an object. And furthermore, we say and acts parallel to the surface. Now, my dear learners, this is what is happening here. If you have an object, right, and your object my dear learners, is experiencing a kinetic frictional force of 3 newtons and there's an applied force of 20 newtons. What you need to realize now is that this object is going to have what we call a net force. We find the term net force and the symbol is F net, and that is what we refer to as the net force. And by definition, we say it is a single force that has the same effect as all the forces acting together on an object. Now, here I have my object. Two forces are acting on this object. One is an applied force of 20 newtons to the right, and the other one is the kinetic frictional force of 3 newtons to the left. Now, in this object, these are not the only forces that are acting on the object, and we must be able to identify all the other forces that are acting on the object. Now, when we know all the forces that are acting on a particular object, that is when we are able to then determine the net force, which is a single force that has the same effect as all the forces that are acting together on an object. Now, for you to determine the net force, the first thing that you must do is you must draw a free body diagram. A free body diagram is a diagram that shows us all the forces that are acting on an object at a particular time. Now, when we draw our free body diagram, this is what we will do. Firstly, we will represent our object using a dot. Then, we know all objects, my dear learners, are being acted upon by the force of gravity, and that force acts downwards. Now, every time you represent a force on a free body diagram, you must make sure that that particular force touches the dot, meaning it touches that particular object, and then you will show the arrow, and that arrow will point in the direction of the direction that the force is acting. Then another force is going to be the normal force. Nominate which one is the normal force. Remember, the normal force is the force that the surface exerts on the object, and it acts perpendicular to the surface. So our box was on the ground, so it means the ground is exerting a force on the object, and that force is going to act upwards. And then again, we must have the applied force. So that is F applied. And then we must have the kinetic friction. Now, when we draw a free body diagram, remember now the line must touch the dot, and you must have an arrow head. that point in the direction of that particular force. And for that 1 mark again, my dear learners, it's going to be for that with the arrowhead touching the dot and also the correct label of that force. So that will carry 1 mark. It's touching there, it has an arrowhead going downward, it has a correct symbol, Fg, for the force of gravity. The same applies there to the kinetic friction. The same applies there to the normal force, and that is going to give you 4 marks. Now, when you look at this particular object, these are all the forces that are acting. Now, my dear learners, we know here that this object is not moving up and down. Now, if my object is not moving up and down, it tells me that the forces that are acting vertically are equal. In other words, the normal force is actually equal to the force of gravity. It means our forces here are definitely balanced, right? The normal force is equal to the force of gravity. And the reason they are balanced is because they are equal and they are acting in the opposite direction. Now, one question can arise, and that question is calculate the magnitude of the force of gravity. Remember now, if you want to calculate the force of gravity, you will then go to your formula sheet and you will find that there's a formula that's written, Fg is equal to mg, also W is equal to mg. So these are the two formulas that you can use. Now, we know the magnitude of the force of gravity is 2, and the value of G is 9,8. Now, if you perform your calculations there, my dear learners, you will realize that this gives you 19,6 newtons, right? That is going to be the magnitude of the force of gravity. Now, because these two forces are balanced and the object is not moving up and down, then it tells me that, oh, the normal as well is equal to the force of gravity. In other words, the normal is also going to be 19,6 newtons. But remember now, this one will be upwards, and then this one will be downwards, right? Now, my dear learners, let us say now they ask us to calculate the net force that is acting on this object. What we are going to do is we are going to say F net is equal to, now remember, we are going to add all the forces that are acting on the object. But because these two forces, the normal force and the force of gravity, are balanced, they are giving me a net vertical force of 0, then I don't have to include them. Then I must just include the forces that are acting horizontal. And this is going to be F applied plus Fk, which is the kinetic friction. Now, from our diagram, we noted that the magnitude of the applied force is 20 newtons. So we are going to substitute 20 there. And we also know that the magnitude of the frictional force is 3 newtons. But remember that we are dealing with forces. And if we are dealing with forces, then you remember that a force is a vector quantity. In other words, it has both magnitude and direction. Now, if it has both magnitude and direction, it means when we do the sum of these forces, we need to take the vector nature of the forces, and we can choose that. Let us say to the right is positive, and to the left is negative. And you indicate that for your marker to make the marking easy. So it means the magnitude of the applied force is 20 newtons and it is positive. So I'll substitute it as positive. Plus, remember now this is to say we are doing the net force. We are doing the vector sum of all the forces acting on the object, and the magnitude of the kinetic friction is 3 newtons. But remember now it is acting to the left, and we said the left is negative, so we'll put a negative 3. Then if we add this, it's 20 into positive times negative, it's negative. So it will be a positive 20 minus 3, and that will give us 17 newtons. And what we need to do is to then interpret the magnitude of, rather the direction of that force. So because it is positive, it's a positive value, then we go and we write, oh, this is 17 newtons, and that positive there is to the right. In other words, the magnitude of the net force here is definitely to the right. Now, as well, my dear learners, you will understand that, oh, if I have a net force that is to the right, it means my object as well is going to accelerate. Why? Because Newton's second law of motion tells us that when a net force acts on an object, the object will accelerate in the direction of the net force. So here I can see that I have a net force acting on an object. It means the object will accelerate in the direction of the net force. In other words, here I have an acceleration. If the net force was 0, then I wouldn't have any acceleration. Now, let us say we are required to then calculate the acceleration of this box. What we are going to do is, we will say, we'll use Newton's second law of motion equation, and that equation tells us that it tells us that F net is equal to ma. Now, I already know the net force that is acting on the object, and that net force is 17. So F net is going to be 17, and this is going to be equal to the mass, which is 2 multiplied by acceleration. Now, remember, when we substitute the net force here, you must definitely substitute it with direction. So the net force was positive, and hence I substituted a positive 17, and that will be equal to, remember now the mass is 2. Now if the mass is 2, I don't substitute direction. Why do I not substitute direction? Because mass is a scalar quantity. It doesn't have direction, and that will be equal to 2 multiplied by A. Then to calculate A, remember now, I must divide this side with a 2, divide that side with a 2. Then on the right hand side, I'll be left with A. Then I will have 17 divided by 17 divided by 2. And that is going to give me an acceleration of 8,5, and remember the unit for acceleration is meters per second squared. Now, if I ask you to calculate the acceleration, you must remember that acceleration is a vector quantity, and therefore you need to give it direction. So you will say the acceleration is 8,5 meters per second squared. And because it is positive, then you will say that is going to be to the right. So that is essentially how you would calculate the acceleration of the object. So it will be 8,5 meters per second squared, and that will be to the right. And it makes sense because now the direction of this acceleration is the same as the direction of the net force. So what are we learning here? We are learning that when you are dealing with a vector quantity and you are substituting it there, you need to give it direction. But for mass, it doesn't have, it's a scalar quantity, so it doesn't have direction, so we will not put our direction there. Then you do your mathematics. Remember, you get your acceleration, and the units are 8.5 meters per second squared, and you definitely need to show that dot. After that, because the acceleration is positive, you need to interpret that positive, and that positive from the original choice of direction was it is to the right. And according to Newton's second law of motion, we are correct because the object accelerates in the direction of the net force, and hence the direction of the net force is to the right, and the direction of the acceleration is to the right. Now, to just recap on this, remember, you can be given an object, right? And when you are given an object, you must be able to draw a free body diagram from it, meaning you must be able to identify all the forces that are acting on an object and represent them using a diagram. So then we're given the magnitude of the two forces. One was an applied force because the man was pushing the object, and the frictional force was acting on the object. Now again, just to emphasize, remember, friction is only going to be experienced if the surface is not smooth. In other words, if our surface is rough, and that is when this object will experience frictional force. Now, if your object is going to the right, then most definitely your frictional force is acting to the left. Why? Because frictional force is the force that opposes the direction of motion of an object. So, if the direction of motion of object to the right is to the right, then the frictional force is definitely acting to the left, and it acts parallel to the surface. So we can be asked as well to calculate the net force. Remember, the net force is the single force that has the same effect as all the forces acting together on an object. In other words, it is the vector sum of all the forces that are acting on an object. So it is basically the ultimate force, that the object is feeling. And sometimes we refer to that net force as the resultant force, or we refer to it as the unbalanced force. Then here we drew a free body diagram of all the forces. Remember, I emphasized to you, you use a dot, and then you use your arrow to represent the force. And that arrow must touch the dot, it must have an arrowhead, and it must have the correct label for the force. Remember now, you are going to forfeit marks if you do something like this, right? Because it is incorrect. This arrow must go through to the arrowhead. So it has to go through to the arrowhead, and we will do the same for all the forces. Then remember again, you could be asked to calculate the force of gravity. Now, if you were asked to calculate the force of gravity, then you would apply the formula that is relevant. And you know that formula, you will get it in your formula sheet. And it shows you that Fg is equal to mg. And from your formula sheet, this is the formula that I am talking about. Fg is equal to mg. That is to calculate the force of gravity. Then, because the forces were balanced vertically, it means the normal force is equal to the force of gravity. And then, if the force of gravity is 19.6, then the normal is also 19.6. Then again, to calculate the net force that is acting on an object, what you need to do is then to say F net is equal to F applied plus Fk. And we do not include these vertical forces because vertically we have a net force of 0. Then we take direction into consideration. F applied plus Fk is the value of the net force. Then our direction, any force acting to the right is positive, hence the applied force is 20 and it was acting to the right. And the frictional force is -3. Why negative? Because it was acting to the left. And then we get a net force of 17 newtons and it's positive, so the direction is to the right. And we can use that again to calculate the acceleration using Newton's second law equation because we know the magnitude of the net force. Right? So it's substituted there with direction is equal to 2 into A, and my A is 8.5 meters per second squared. And because it is a vector, then I will include my direction, and it will be the same as that of the net force. And obviously, as I have chosen my direction, a positive value means the object is moving to the right-hand side. So that is essentially what you need to be able to do in terms of drawing free body diagrams. Now, furthermore, my dear learners, there are quite a number of questions that you could be asked and you must be able to answer them. Now, here is a question that I want us to look at. It is question number 3, and I want us to work from 3.1 all the way up to 3.6. Now, let us look at the question that was given. Now, if you look at this question, it's a question on Newton's laws of motion, and it is quite a nice question for starters, and you can see that this question is from the Technical Sciences Control Test from March 2020 in the pre-state. So I want us to look at this question, and I want us to really do our best to answer the question and see how we can collect the marks. Now, what we are seeing here as well is an object has been given, and they are saying to us a block with a weight of 50.96 newtons. So they are talking about the weight. Now, when they talk about the weight, you definitely know that they are talking about the force of gravity. Remember, that is another term that we use for the term weight. Now, they say to us, is at rest, right? It means it's not moving on a rough horizontal plane. Immediately when they say to us it is rough, then you already know that it means there is a force of friction. When a horizontal force of 10 newtons is applied to the right, the block accelerates to the right at 1.6 meters per second squared. Now, what does this tell us? It's basically telling us that at the beginning, this object was just at rest. In other words, it was stationary. In other words, it was not moving altogether. Now, if it was not moving, then someone comes and they apply a horizontal force of 10 newtons that is going to the right. Then, so the object then starts to move, and they tell us it accelerates to the right. Automatically, that tells me the net force is also to the right. Why do I know the net force is to the right? Because the acceleration is to the right. And Newton's second law of motion tells me that when a net force acts on an object, the object will accelerate in the direction of the net force. So net force and acceleration will have the same direction. Now, question 3.1, they say to us, we must draw a labeled free body diagram to show all the forces acting on the block while it is moving. So what we will do is, you will remember now, they want all the forces when the object is moving. So according to this, remember for a free body diagram, what we definitely do is we start with our dot. Now, the force of gravity is definitely acting on the object. Again, this object is on a surface, right? A rough horizontal surface. So the surface is there. Now, if you have a surface, it means there is definitely a force that the surface is exerting on the object, right? Which is the block. So we know that force is the normal force. Then again, we can see that there is an applied force to the right. So you will write there F applied. And again, there is a frictional force acting on the object. And because the object is moving, we know that frictional force is your kinetic friction. So these are all the forces that are acting on the object. Here I will get a mark. Why? Because the label is correct. The arrow is touching the dot, which is the block, and I have an arrowhead, and the direction is correct, and the same applies there. So that is how I'm going to get my 4 marks. Altogether, my dear learners. Right, let us then move to 3.2. Now, if we go to 3.2, then you will realize that they are now asking me to calculate the mass of the block. Now, how would I calculate the mass of the block? Now, it's really not difficult at all to calculate the mass of the block. What I definitely need to do there is to say, oh, I've been given the value for Fg, and they told me that Fg is 50,96 newtons. Now, from this formula, I know that the force of gravity is equal to mg. Now, if I know that the force of gravity is equal to mg, then what I'm going to do there is just to substitute the magnitude of Fg because it was given. And we know our Fg is 50,96. And this is equal to m, which is what I'm looking for. And I will multiply by g. And the value of g, remember, you will get it from your data sheet. And there it is given. And the value is 9.8 meters per second squared. So I now know what is the magnitude of the force of gravity. In other words, there I am going to substitute a value of 9.8. So that will be multiplied by 9.8. And to calculate the actual mass of the object, I'm going to take my 50 and I'm going to divide it by 9.8. Rather, I'm going to take my 50.96 and I will divide by 9.8. And the value that you're going to get there is definitely 5.2 kilograms. So that is a relatively easy calculation. Then 3.3, we are required to write down Newton's second law of motion in weights. Now remember, I told you You must get it definitely from where? From your examination guidelines. And it says when a net force acts on an object, the object will accelerate in the direction of the net force. And then it says acceleration is directly proportional to the net force and inversely proportional to the of the object. So when a net force, remember that with net must be there. When a net force acts on an object, the object will accelerate in the direction of the net force. Now, my dear learners, remember acceleration is due to net force. So at all material times, let us talk about net. I know when we mark, we definitely want net force there. So that will give us a mark. Yes, even though you don't have net force there, it's fine. But there, the weight net must be there. But to make it easy for yourself, because we are dealing with net force, acceleration, and mass here in Newton's second law of motion, it's easy to get used to dealing with net force and writing net force because this is absolutely correct. And furthermore, it states acceleration is directly proportional to the net force. That is the second mark because you are given the relationship between acceleration and net force and inversely proportional to the mass of the object. So there you are given the relationship between acceleration and mass. That will give you 3 marks. And I prefer to talk about net force at all material times because then I am 100% correct. Then the next question says, what is the direction of the, or rather 3.4, they want us to calculate the magnitude of the net force that is acting on the block. Now to calculate, your net force, you will say F net is equal to MA. So the magnitude of the net force is what you are looking for. So we are going to deal with that. Then our mass is what we calculated in the previous question, and we know it is 5.2 kilograms. So we will substitute there 5.2, and our acceleration was given. And if we say to the right is positive, it means there we will substitute a value of 1.6. Then to calculate our net force, we will say 5.2 and we will multiply that by 1.6, and that is going to give us a net force of 8.32 newtons. And because the value is positive, that will give us 8.32 newtons, and that will be to the right. Why is it to the right? Because the value is positive and we chose to the right as positive. So our acceleration, rather our net force there is going to be 8.32 newtons to the right. So how do we allocate our mass there? it will be 1 mark for that, 1 mark for the substitution, as well as 1 mark for the magnitude, as well as the direction. And rather, here we should actually just end there, actually, right? The mark will be given for the magnitude only, because the question required us to calculate the magnitude. But remember, my dear learners, if they just said to us, calculate the net force on the block, then the net force would have been 8.32 newtons to the right, because when we say net force, you remember it is a vector, then you would have given both magnitude and direction. It means this would actually carry 4 marks, but in this instance, it carries 3 marks only for there and there and there, because they only wanted the magnitude. Right. Then for 3.5, they are asking us, what is the direction of the net force on the block? And that answer is very simple. Our answer is that it is to the right. And there they were very generous with the marks when they said, what is the direction of the net force on the block? It's to the right. How did you determine that? Because the acceleration was to the right. So there you're going to get 2 marks. And now we are required to calculate the frictional force that is acting on the block. So to get the magnitude of the frictional force, you will then check what has been given. So you now know the magnitude of the net force. You now know the magnitude of the force that has been applied. So it is easy for you to actually calculate the magnitude of the frictional force. Remember now, based on our free body diagram, when we deal with the net force, we said it is the vector sum of all these forces that are acting on the object. But these two forces are balanced vertically. So we have a net vertical force of 0. So now, so for now, what is happening is, because these two are balanced, we will not include them on our calculation of net force. We will only include the forces that are vertical. So that would mean if we wanted to calculate F net, I would rather the frictional force, I would say F net is equal to F applied plus Fk. Now I know the magnitude of the net force, and it is 8.32 newtons, and the direction is to the right. And remember, we said the right must be positive, and hence I substituted the value as positive. And the magnitude of the applied force, remember, it is 10. This applied force is 10 and is to the right. Hence it is positive, plus the magnitude of the frictional force, which is what I am trying to solve for. Now, remember, I'm solving for this value, and if I'm solving for this value, I cannot, if I'm solving for this value, there is no way that I can give it direction. The direction will work itself out, right? So you don't give Fk direction and say it is negative. Otherwise, you will end up with a value that is positive, and that becomes incorrect. So I try and solve for Fk. To do that, it will be equal to, I transpose the 10 to the left, so it will be negative. So this will be 8.32 minus 10. Then to calculate my Fk, I'm going to say it gives me 8.32, and I'm going to subtract 10 from that one, and it will give me a negative value of negative 1.68 newtons, because we are calculating force. And remember, they said we must calculate the frictional force. In other words, we have to give it direction. So And furthermore, you cannot leave a vector quantity negative. So Fk will then be 1,68 newtons, and I will interpret the negative, and that will be to the left. And most likely there, our mark allocation is 1 for the entire expansion of F net. Then the other mark will be for substitution, and the last mark will be both for the magnitude and the direction, and that is how you will get your 3 marks. In a nutshell, my dear learners, that will mark the end of our lesson, and tomorrow we will do more of these questions, but then we will be dealing with 2 body systems. This one, it was just a 1 body system, so we'll be dealing with 2 body systems tomorrow, and we'll be calculating things like forces like tension and so on. So that is that, my dear learners, and I hope you have definitely learned something. So that is what we had for today. We were just looking at applying Newton's second law of motion using 1 body system. In our lesson tomorrow, we will be using Newton's second law of motion, and in that case, we will now be applying our Newton's second law of motion to 2 body systems. So thank you very much for tuning in today. I will see you again tomorrow, same time, same place. Thank you very much. Enjoy your evening.